Okay, so let's make some guesses here. I'm going to guess that this cell here is pushing current this way. Okay, I'm going to guess that this cell whose thing got erased, okay, this guy's going to push current this way as well. Okay, and then I'm going to guess that the current here is going to go this way. So I'm going to call this I1. Now remember, if you guess wrong, don't worry about it because you'll just get a minus sign. You can't get it wrong because there's just science here, you know. Okay, and so if I look at this junction, let's look at this junction right here. Okay, just for kicks, we know that in, let's do the junction rule. So in equals out. Okay, so I1 is flowing in, right? And I2 are flowing in. So I1 plus I2, okay? And I3 is flowing out of that junction, okay? So if I make this into matrixable form, it looks like this. It's I1 plus I2 minus I3 equals 0. And we're done with our junction rule here. Okay, so now let's do a clockwise traverse of this left side, and I'm going to start at that same junction, end at that same junction here. Okay, notice I'm going upstream through the 12, upstream through the 11, the wrong way through the 38 volt one, so I'm going to go down 38. Then I go downstream through the 13, downstream through the 14, and I'm there. Okay, so let's start with upstream. So plus 12 I1 plus 11 I1, because I'm going upstream, right? Down 38, because I go from the positive to the negative side, right? Then I go down 13 I2, down 14 I2, and then that equals 0. So let's try this again. Okay, upstream, so plus 12 I1, plus 11 I1. Down 38, let's see, now we're going downstream in I2, right? So down 13 I2, down 14 I2, and now we're back. Okay, so let's write this in correct matrixable notation. This is 23 I1, right? I1, how much I2? Negative 27 I2, 0 I3, and then we got to put all these constants on the other side. There's only one constant. Okay, so that equals 38. Okay. Okay, this is good. This is matrixable. We can put that in our matrix. Okay. Now let's do a loop here. I'm going to start at the same junction there. I'm going to go clockwise. So I'm going to go upstream through the 14, upstream through the 13. I'm going to go the wrong way through the 13 here, okay? Then upstream through the 9, upstream through the 8, upstream through the 7. Okay, so here we go. So I'm going to go clockwise. So let's see. Plus 14 I2, plus 13 I2. Okay, now we're going the wrong way through this guy. So minus 13. Okay, now we're going upstream in I3, right? So plus 9 I3, plus 8 I3, plus 7 I3. And now we're back. We're back to the thing. Let's double check. So upstream 14, upstream 13, and those are both I2. The wrong way through the 13 volt, right? Okay. And then upstream on this guy, 9, and then 8, and then 7 I3, and then we're back. Okay, so let's write this down. It's 0, 0 I1, and then we have plus 27 I2, and then how much I3? 9 and 8 is 17. Is that, what is that? 9 and that's 17, that's going to be 24, right? So So plus 24 I3. Is that right? Okay. Oh, no. Okay, I'm good. Okay. Let's see. And then what are our constants? Is that equals 13? Okay. Okay, so let's see how much room we've got. Okay, we got right about there. Okay. So let's draw our matrices in here. There we go. Okay. And I've got 1, 1, negative 1, and 0. So 1, 1, negative 1. Okay, I'm going to invert this matrix, right? And then that's going to equal I1, I2, and I3. Okay, so let's see. So 1, 1, negative 1, and then in the top here we got a 0. The next one is 23, negative 27, 0, and then that's 38. This guy's 0, 27, 24, and then on the right side here is 13. Okay. All right, are we ready? I think we're ready for this. Okay, let's turn on our calculator here. And let's go alpha F3. We want 3 rows, 3 columns, and okay. 1, 1, negative 1. Okay, then 23, negative 27. I'm going down there, let's see. Then regular 27, right? And 24. And I think I've got my first matrix set up correctly. 1, 1, negative 1. 23 minus 27, 0. 27, 24. Okay, and then I inverted that. So I just hit I got to the right of it. I hit the inverse button there, right? Let's stick another matrix here to multiply it by. This one's going to have 3 rows, but only 1 column. And up in the top there's 0, then there's 38, then there is 13. All right, now prepare yourself for the shock. And that is that we guessed wrong about that middle current there. Okay? That middle current is not, see how that's negative, right? So it's not down. The middle current is actually up. Okay? So what I do at this point is, since I see that, right? Do you see how that's negative? Okay. As soon as I see that, I actually just correct it on the picture that I drew. Okay. Whoops. Hello. There we go. So notice I said it was down. It's actually up. So I'm going to go up and up and up, and I'm going to get rid of that and make it like a thing like that. Okay. It's actually up. Okay. So they are down through the 11, up through the 14, and up through the 8. They are down, up, up. Okay. Now let's grab those numbers out of the matrix. Whoops. Okay. So I'm going to store this guy in a matrix. So I go second matrix, just store it in A. You could store it in anything you want. I'm going to store it in A because it's easy. Okay, and now I'm going to address these things. So second matrix A, and then you can go parenthesis 1, comma 1. That addresses the first row, first column. I'm going to store that in the letter A. And then, oops, I'm going to say the opposite of the next one because I don't want a negative number. The opposite of this guy. So this is the second row, first column. I'll store that in B. Hopefully this will end up being a positive number. Indeed, there we go, right? Okay. And then I'm going to take the third one. So let's go up here, grab this guy. And let's go the third row, first column. Let's store that in C. There we go. Okay. So now I've stored those things in the variables. Let's fill in the thing here. So this is 1.257 amps. The 14 is 0.3366, roughly 3 amps, right? And this guy is 0.92037 amps. And I've stored this in the variable A, this one in B, this one in C. This is very handy, right? Okay, so 13, let's find 13. 13 is there, right? So that's going to be V is IR. Okay, and that's going to be specifically I2 times 13, right? Which for me is just going to be, this is I2, right? This is I1, I2, I3. So literally I'm just going to go B times 13, okay? B is 4.38 volts. Okay, let's see, the 9 one, no, V is IR, right? Where's our 9? Our 9 is there, so that's going to be 9, I3 times 9, right? Okay, or 9C for me, right? That's 8.28. Okay, power dissipated. Power is I squared R, right? But for the 12, where's my 12? There it is, right? It's going to be I1 squared R, right? Times 12. Okay, well, I1 is this guy, the 1.257. So for me, it's just A squared times 12, right? $18.96. I'm just going to write it that way, 18.96. There it is. It's 19.0, right? With 3 sig figs. That's watts. Okay, and then 7. Where's my 7? There it is, right? That's going to be I3 squared times 7, right? So for me, it's just C squared times 7. Because I stored I3 in C, right? 5.93 watts. And now the dreaded V1. Okay, so I'm going to go, this is my left side. This is my right side. And so for V1, I'm going to go left to right. You don't have to go left to right. I just try to just always clockwise, always left to right. Okay, and I'm going to do the lower route, left to right, and then I'm going to do the upper route. Let's do the lower. Okay, notice for my lower route, I'm going to go upstream through the 14, downstream through the 7, downstream through the 8. Okay, so it's going to be plus 14 I2, which is this guy, right? Okay, and then it's going to be minus 7 I3, minus 8 I3. Okay, so 14 alpha B minus 7 alpha C minus 8 alpha C. And this is negative 9.092. So I'll say negative, for the sake of this, negative 9.0928. So that means that this side is more negative and this side's more positive. Because we went from left to right, we went down in potential, right? Okay. Now let's do the upper route. By the way, if we don't get the same thing on the upper route, then something's wrong. Okay, so now I'm going to go downstream 13I2. Then I'm going to go down 13. Just plain old 13, right? Then I'm going to go upstream through the 9, so plus 9, I3. Okay, so let's just double check. So downstream 13I2, down 13, then up 9. So for me, that's negative 13 alpha B minus 13 plus 9 alpha C. Hello. How about you don't be twitchy? There we go. We get, whoa, exactly the same thing, right? This is awesome. Hello. Okay. So that is negative 9.0928 volts. So we get exactly the same thing, right? If you get two different numbers here, then something's wrong. You messed up something somewhere. Somewhere there's a problem, okay? So I'm going to say negative 9. I'm going to say 9.09. That's the absolute value of it, right? And I don't need you to necessarily know for this test which side's positive, which side's negative. But I've seen it on the IB test, so I'm just going to say that perhaps, anyway, you might need to be able to know that.